Hey everybody, this is Barry Mankin here with the Holistic Home Health Podcast. Hope you're having a good day. We're having a wonderful time here with John Ellis. And we already had the first half that we did last week. We're going to get a little bit deep on this next episode here. So, John, I wanted to thank you again for coming. And we're looking forward to getting a little bit nerdy on this one and talking about how your heart applies to the technical side and basically the process between the diagnostic and that solutions side to help people with their indoor air quality. So thank you again for coming and being here.
Yeah, it's been fun. My pleasure. Appreciate you having me.
Absolutely. So why don't we talk about general concepts as it relates to, the building science and the performance side as it relates to the mechanical science, and how that applies to, once we have, we start out diagnostically, because that's where we start out, and I know that's important on your end. The way you approach things is very similar, and so I would just say just give me your concepts on those two main subjects, and we'll do kind of a broad stroke, and then we'll get into the weeds however you want.
Yes, I think the most important thing to understand on both your side and more on the mechanical side, it's science, but we have to be data driven, because assumptions and rule of thumbs and different things will get us all in trouble.
Yeah, numbers don't lie; people do.
numbers don't lie, and so with gathering data comes tools, and being a musician, there was always that, well, you're only as good as your equipment. It's nice to have good equipment,
right?
But it's us that make it happen,
right?
And so we have to be data driven.
Yeah.
But we also have to have some pretty reliable equipment to gather that data. And there's a phenomenon going on right now with clients having little indoor air quality monitors
right.
that they get off of Amazon for $120. And then they're basing their reactions off of that. And then we come in with a little more sophisticated monitoring
and know how to use them
and know how to use them and placing them right. And it will either affirm what they're getting or it'll debunk it.
Right.
And so I've had some little tug of wars with a few people that just swore that their $120 meter was right and my $5,000 meter was wrong.
Right.
But that's okay. But so we need to be data driven. There's also a lot of talk now. All of our industry is getting more technical, and there's more and more things coming out, and then things get obsolete. But data integrity is going to be imperative.
Absolutely.
And so it's real easy to take an air sample or something and then it's compromised because you didn't handle it right or didn't do it right. And so data integrity is going to be important as well. And how we achieve that, as well as I do, having our equipment and then having it recalibrated.
Oh, yeah.
And then recalibrated and the expense to that. Yeah, it's not cheap.
You ain't kidding.
But when we talk about data integrity, it's imperative.
Absolutely.
That you keep your instruments up to date on calibration. And so then as we look at data, then there is how we interpret the data. And there are some people that have a difference in opinion on what those numbers mean.
Oh, yeah.
And that's okay, but we're given a set of standards from top down again on what we're looking at as a range, if you will. And like I said, like a lot of the authorities say, hey, 50% relative humidity is kind of our sweet spot. Well, that's a range, and it's not for all people everywhere. So that's it. And then when we look at ventilation standards, ASHRAE 62.2 being one of them, we have to understand that building codes and some of those standards are a minimum standard. And I think we mentioned, you started at a D-. Well, that was passing.
Right. Great job.
And our building codes are minimum.
Yeah.
And a lot of things get missed. It's like, well, did that get installed before lunch or after lunch?
You're right. Yeah.
Yeah. So that's important to understand, that we need to be data driven. And then there's some scientific concepts that are behind these things too. And so when we talk about building science, what that is a set of measurements. And we know how the built environment is supposed to go. There was a set of blueprints or plans that were drawn by somebody, an architect and an engineer, and you got the structural guy, and they all go together into this big mixing bowl, and then you get a project. And so we know how it was the end product was supposed to be, but it doesn't always end up that way for several different reasons.
Right.
And that's okay. Human nature. If we had robots building everything, maybe things would be better, but or maybe not.
Right.
As we're looking at the built environment, remember we're trying. The end goal is we're trying to achieve safe, healthy, sustainable, durable, comfortable. Right. That's the environments we're trying to create.
Yeah.
And then so when we look at and one thing I teach in my class is the why never changes.
Right.
But the how does.
The how is everything.
And so that's something that how I did something in California, Arizona, Utah, Nevada is a lot different than how I would do in Tennessee, Georgia, Florida, Alabama.
You're going to get me on a rant if we start talking about that.
Yeah. But when they put standards out, they try to make them generalized. And so different places and climates try to adapt kind of like an umbrella kind of thing, and it just doesn't work that way.
Right.
Then there's universal codes, and then there's state and municipal codes.
Right.
And they vary different all over the United States.
Right.
And so we have to understand that as well. So when we're looking at, we built some foundation on the last episode, and so we look at some of the subcategories as we look at thermal comfort. Well, what does that mean? Well, it's going to be different for different people. And I run hot. Yeah. My wife runs cold.
Right.
And so we're constantly, turning it up, turn it down. It's like, well, what do we do?
Right.
And so we have to find that happy medium.
Sure.
And so thermal comfort's going to look different. And then when we look at humidity, again, people are going to respond different than what we look in general terms for the building or the structure. Our mucous membranes are our filter. I am the filter.
Yep.
And so
correct.
at different humidities, people will respond differently. And so we have to be able to have a balance between what we need for structure integrity and the building, and not to be conducive of any kind of microbial. And then what do we need to do for the human to be comfortable in our, our bodies?
Yeah.
And so that looks very different. And it's a balancing act, and finding that equilibrium can be tough.
Absolutely.
Yeah. But those are some of the challenges that we face. Keeping outside out and inside in is also a challenge in how we do that.
It seems like that what we have today, we spoke about the houses being so much tighter now than they used to be. It seems like so many houses, since we're at a D-, it's kind of like all or nothing in order to really achieve what we need to achieve, because everything is steering us to where we have to have total control of everything. And that middle ground, most homes are kind of like in that middle where there's just all this tension, and there's no easy solution without like steering them into control, unless the house is completely constructed like old school and it is, breathing and they don't have the HVAC going on, and, that's a different character. But once we introduce HVAC, we start buttoning things up, everything's off the table. It's kind of like, okay, you have to go in this direction.
Sure. And different building practices in different parts of the country.
Right.
So are we slab on grade?
Right.
Right. Are we crawl space?
Right.
Are we basement?
Yeah.
Are we metal roof? Are we asphalt roof?
Yeah.
Are we spray foamed? Are we traditional?
Yep.
Right. I always joke about Energy Star homes.
Yeah.
They're the least energy efficient home that we're legally allowed to build. But they put their little star on it, and it's a
right.
Yeah. Could we do better? Well, yes. But for every action, there's a reaction.
Yeah.
Causality. So we have to understand that when doing that, we have to look at the whole picture. The building is a system.
Yeah.
So in doing that tight home, where are we at? And then what are we bringing in?
Right.
And I've got plenty of stories where just the flooring or the carpeting or the adhesives that were used or the furniture they brought. I had a call just recently, and they're experiencing TVOCs. It's like, did they get any new furniture? Yes, that's what it is.
Yeah.
They got a new couch last week.
It's going to off-gas.
And it's going to off-gas. So those are all things that we need to keep in mind. And so then when we're looking at the air, we need to figure out what's in the air. And I like to, when I'm looking at pollutants in the air, I've got another subset of categories. Synthetic, organic. And so is it organic? Is it mold, bacteria, microbial, dust mites, rodents, different things? Is it organic, or is it synthetic? And we're talking about chemicals, TVOCs, different things like that. In the spectrum of clients, there are people who have chemical sensitivities, multiple chemical sensitivities, and they're very reactive to molds and spores. And people are really reactive to rodent feces or cat dander is a good one.
Yep.
And so being able to identify and separate those out. A lot of folks, if they have gone to their allergist and done the pinprick thing for different things, can have an idea. But then so we're looking at pollutants. We got synthetic, organic, and then the wild card would be surrogate. Surrogate pollutants are tough, and to help our audience understand what a surrogate pollutant is lots of folks say, well, mold can't grow on fiberglass because fiberglass is synthetic and not organic. I'm like, yes, but the dust and the schmutz that gets on the fiberglass can hold it.
Can you define schmutz?
It's a technical term. It's Yiddish.
Okay.
And it's for like dirt.
Schmutz.
Yiddish.
Okay.
It's Yiddish.
Use that term.
Yeah. But surrogate pollutant also. So we look at our HVAC system.
Yeah.
And we've got the coil that stays wet because that's its job to take care of that latent work, remove the moisture out of the air. But because it's wet, different building components, components start to break down. So the rust can start to break down. It can fall in the pan, and then the pan can get schmutz on it, and that schmutz has the mold, and it can become aerosolized. And so when we're gathering samples, whether it's an air sample or a surface sample, we're putting it under a microscope, and we're looking for a certain physical attributes on how different spores and things look. If we get an air sample that is actually rust with a mold spore or something on it, we're not going to be able to identify it by just that.
Right.
So surrogate pollutants are really tough. Wool is another one. Depending on where that wool comes from, how it was processed, higher end wool is a little better, and how it was processed out. Wool is animal, and so that hair frolic can have within it, depending on how that animal was raised, if it was laying in its own swaller and or wasn't processed right, and then used for creating clothing or fur, and if it could have those pollutants come out, and those are in the form of enzymes.
Yeah.
And the same with roach and dust mites and anything that has an exoskeleton. As they shed their exoskeleton, they release an enzyme, and sometimes that enzyme, and then their feces. And so, I mean, it's not all gloom and doom. This is just some of the challenges that we have when we're trying to identify pollutants on both sides of the spectrum.
Right.
Yeah. And so now we've got a pretty solid identification. We think we know what's going on with that. And it's like, okay, so we talked about offense, defense.
Yeah.
And so maybe some good cleaning. Okay, but clean what?
Right.
And so this is where pollutant identification. So we've identified it, and maybe we have some things on both sides.
Or
of the
even
spectrum.
location.
Source control.
Yeah, exactly.
So people want to do cookie cutter approaches, and they go in and they just do all this stuff.
Right. They're just
But
throwing
if-
darts at the wall.
So spaghetti.
Yeah.
Hoping some noodle sticks.
Hey, it works for me.
Yeah, it's a spaghetti. But so now we're faced with a challenge. So if we don't identify the pollutant and we put a blank, like you hear the term TVOC thrown around a lot.
Right.
That is total.
Right.
We have like 16 that we pay attention to, and there's some outside of that.
Mm-hmm.
If we can't start separating them out and we don't know what they are, we don't know where to go find them.
Right.
Thus identifying the source or the pathway. And then once we identify the pollutant, is it inside or outside? Is it something we brought into the space and we can go ahead and handle it? Or is it something outside getting in, and now can we offset our pressure imbalance to go ahead and eliminate that?
That goes to smells and all kinds of things.
It does. And smells are tricky.
Smells are tricky.
They're real tricky.
But it's the principles are the same.
They are the same. Air is the medium on which all things travel. Air moves in and out of a structure depending on pressures and then what's driving that pressure differential. And so if we can help nail that down, that gets us to minimize our air movement in and out of a space. And then air is a fluid, so we have to understand that.
Yeah.
It has no shape of its own, takes the shape of the container it's in.
Right.
We're in a container, our lungs are a container, a duct system is a container, a house, get in the car and shut the door. This is a container. So it's fluid, has no shape of its own. Air, which is a fluid, is the medium on which all things travel, period.
It's interesting that you're using that analogy because it's that glass half empty and half full kind of thing. The other half of that bottle is the air, right? So they're both doing the same thing within the same container.
Sure. And the air is one molecule away from becoming the water.
Right.
And so these are all concepts that we have to be very cognizant of as we're getting deep into our diagnostics.
Right.
Hey, I've got a pollutant. That's great. You've identified it. Now I need to know where it's coming from. Is it in the house? Can we take care of it, or is it outside coming in?
Yeah.
And so then building pressures, if we're looking at infiltration, we have tools at our disposal that allow us to measure that, qualify and quantify. And then what can we do to reduce that? And then as we're talking about building science principles, even though we're talking about pollutants and everything, there's a certain amount of physics that are involved, and you can't get away from physics.
No.
And it's math,
Right.
and numbers don't lie.
Again,
So certain physics or things that go on in a home, we cannot stop, but we can slow it down.
Correct.
And so when we're looking at radiant gain and things that happen from radiant and solar gain, insulation slows that process down, but it never stops it. And so then air's going to move depending on what the driving force is. And unfortunately, our mechanical is one of the biggest movers of air in a space. Yeah. And then you have wind and stack, right? But I often go into a home and baseline a home and thinking, oh yeah, I'm probably going to be neutral. And I set up my gauges and I'm like, I'm the only one in this house. All the doors and windows are closed and I'm in a negative pressure. Can't be. Always. But as we look at physics and the air molecules start to heat up and expand and contract, they start to move. You know, the colder air will fall, the hotter air will rise, and now we have convection loops going on in a space, going on in walls, going on in our attics, and then you introduce wind. Right. And then now things change rapidly.
Yeah, and your pressure plane changes all the time.
Yes, the pressure plane. And being able to identify where your neutral pressure plane is, we talked about that. This is tricky because once you identify your neutral pressure plane in the home, then you're going to be able to make a educated scope to so if your neutral pressure plane falls lower, then your predominant shell leakage is going to be lower. If you find your neutral pressure plane higher, then the upper part of the building would be where you would go for your air loss reduction. And so, and chasing that. That's why duct leakage is huge.
Yeah.
Because duct leakage moves that pressure plane.
Absolutely. Yeah. I wanted to get into some of the solutions as well, but let's talk a little bit more on your specific process. Just a couple of general points on how you would go about a diagnostic process and what that looks like. Again, just general points, and then we'll get into looking at solutions and both on the mechanical side and on the building side.
Sure. So allowing the data to pave the way, to point me in the direction, is first. And so then let's just say, and this is something everybody can identify, hey, I've got a dusty house. Okay, so we need to gather some data and figure out why you have a dusty house. And so as we're doing that, our data can point us in a few different directions. If I have high infiltration, there's probably a good chance that dust is coming from pulling dust from outside of the building.
Yeah.
Now, there's always going to be a certain amount of dust that's in the space. Just the simple thing of us going out in the world and coming back, we bring dust particles with us. We wash clothes. You got the dog, the kids running around, whatever. There's going to be a certain amount of dust that's always going to be in the house.
And their interstitial wall cavity, too. It's in there as well.
But if we were to take a sample of that dust, that might be able to tell us a little more of what's going on and where it's coming from. But good chance that infiltration adds to that. And so now, what would be the solution for that? Well, one, can we change the pressure in the house? Can we at least get to neutral? Can we, and we would do that by introducing ventilation. Is the house so leaky we would never achieve that without an astronomical amount of air? And so is air loss reduction, air sealing, is that it? Right? Is it our doors and windows? And can a weatherization approach help us with that? Can we put gaskets on all the receptacles, right? That's something that I
simple solutions in some of those cases.
Some of it is simple. Some of it can be DIY.
Yeah.
Do we have umpteen million can lights in the house that just made Swiss cheese out of our pressure boundary, right? Can we do a seal package on those? Right. And so then, do I need better filtration?
Always.
Do I have leaky ducts? And that's where the dust is being pulled in. So you see, hey, I've got dust. Okay. It's not as simple as one would think to rectify that problem, to find a solution. So dust, it could be infiltration, which would need air sealing, could possibly need a positive pressure apparatus. It could be the filtration, right? Which we could do better filtration. And is it a leaky duct system?
Right.
And equipment. So we need to do air loss reduction on this. So just, hey, I got dust. There's 4 possible solutions for that. It could be one, it could be all 4.
I love your mindset and how you approach things because of your mechanical background, you understand how air moves better than anybody. And in my industry, where we come from, we're looking at things from a diagnostic approach, but we don't have necessarily, at least in my industry, that mindset where we're just thinking about pathways. We always want to get to the sources. Like that's a shared thing, but understanding how it's getting to you and how the exposure is happening, we just say, okay, you need a remediator, you need, an HVAC guy. We're just pointing to, that we just have to have a better number. A lot of times, because depending on what level of an environmentalist you are and how far you go with your business model, how you help people, you're going to get them to a certain point and say, okay, my number's better, great. Or you're going to do an inspection on that home and start to get dirty and get into those kind of areas that a lot of people don't get into in my industry. Or you're going to do a level of diagnostic that includes where's all the air coming from. that's a whole different level. And for you to have that concept and apply that the way you do, I think is something that is missing to some degree in my arena. And I think that's huge because it goes directly to exposure.
What's missing in ours too? There's only a handful of guys out there that are actually doing pressure mapping.
Yeah.
And so that's room to room.
Yeah.
And WRT with reference to. And so we can do room to room. Pressure mapping is what I call it.
Right.
Some guys call it zonal pressure, but I've always called it pressure mapping. We do moisture mapping.
Yeah.
Yeah, we chase
we
moisture,
do that.
see where that's at, and whether it's air or surface. And then, but our WRT is our pressure imbalance with reference to the crawl space,
Right.
a basement, outside, a garage. Is it the attic? So we have a pressure imbalance.
Yeah.
Okay, with reference to what?
Yeah.
And that's where we have a pressure imbalance, and then that's where they stop short.
Yeah.
And it's okay because now we're talking some people are involved in their trades and want to be the best in their trades, but then now there's all these other things that so one of the biggest impacts on a load calculation on a home is infiltration.
Yeah.
And it's
Absolutely.
discounted. And then of course then insulation. And they want to discount it.
Yeah.
Yeah. And so those are some of the things that we want to keep our eye on.
We've alluded to some of these solutions a little bit. So sealant packages are big, right?
Yeah.
And they're practical that anybody can really do. Always source first, right? But pathways, especially when that source may be a little bit, we're talking about percentages in some cases, and we just want to remove anything behind an interstitial wall cavity, what could be coming from the outside, slow down a rate of influence depending on how that pressure is happening, so that it just doesn't have a pathway, it doesn't have a draw in from the outside or from within from a crawl space. We always talk to people all the time about, we have a lot of crawl spaces here, and how to say, hey, just seal the penetration points in the floor throughout the floor and start to isolate that. It's not going to be perfect, but you're at least going to get most of the paths of least resistance.
Sure. Yeah. Basically
for that influence.
Or we can go all the way and do an encapsulation, complete with dehumidification.
Yep.
A lift station, so we can get rid of the water.
Yeah.
And then
sump pump for you kids that don't know what a lift station is.
Oh yeah, sump pump. Yeah. And so then let's touch on humidity.
Yeah.
Let's start with high humidity. Okay, we got high humidity. So what do we need to do? Okay, well, where's the humidity coming from? Well, if we're living in a humid climate, probably from outside. So guess what? Infiltration, right?
Yep.
Leaky ducts. See the theme there?
You go to your doctor for that too, by the way.
And our system performance.
Yeah.
And so system performance is measurements that have to do with the HVAC. And so we look at static pressure, airflow, air exchanges per hour through the system as it pertains to the space, how tight are the ducts, and we want to get to as close as we can in the field to the laboratories or the manufacturer specifications. Air conditioning does work. Air weighs 1.08 pounds per cubic foot at sea level. And we're moving 2,000 CFM. And so that's 2,000 some odd pounds of air. That's some heavy lifting. Of that work that an air conditioner does, there's two sides, latent and sensible. Sensible is just changing temperature. We're just going to change the temperature of the air. Latent is removing the moisture out of the air. That's where the rubber meets the road. Okay, so we're pulling that moisture out. So that's a little more heavy lifting than just changing the temperature. And so in order to control humidity in a space just by way of the air conditioning system, our sensible latent ratio has to be right for that environment. And if we can only achieve, so if let's say we're doing 70-30. So we're doing 70% sensible, 30% latent, and that's the best we can do with that equipment selection. And the way we control that is by slowing down the air. But then there's a fine line to slowing it down too far and losing our refrigeration cycle, and then all bets are off.
Right, exactly. It's a balance.
Yeah, so we get, and we like to set our airflow to our sensible heat ratio, right? Which we can be determined when we do a load calculation and taking some measurements from the house. And so once we get to we get our system dialed in, that sensible latent ratio is just right on, and we're still having humidity problems. Now we have to go to supplemental dehumidification, another piece of equipment.
Right.
Yeah.
Or we're back in our realm. We're going, hey, let's find the sources. So if I can eliminate the sources of where the water is infiltrating the house, whether it's just as simple as like, hey, manage the grading outside, the gutters that are dumping right there at the foundation that's getting into the crawl space and the house is drawing it in. Get it to the source of the water and do all of that first instead of that, and then let's see what we've got left. In the case I talked to you yesterday, we had somebody with a brand new house. They're on a slab foundation. That slab is curing for, I told them, at least a couple years, right? And you're telling me that it could be up to 5 in some cases, depending on how that reintroduces and the vapor barrier and all the things that are associated with what's under that slab.
And the mix.
Depends
on the mix too.
Yeah, the permeability of that rock, So all of that is influences what we have to manage in the home. And so I always come from the point of like, hey, let me look at the gutters, and you have the solutions on the other end, and be able to actually apply different applications of the mechanical to manage that. So if I can, on my end, come out and just take that percentage of influence down as much as possible, just like isolating, what's coming through the walls. If we can slow that down first, then we see what we've got left that we got to manage. If we still don't have performance, then we're getting like somebody like Nathan here locally to come in and say, all right, here's what we got left.
Yeah. If our humidity is coming in because of infiltration, that has to be addressed first.
Absolutely.
We got to do air loss reduction. That's
absolutely.
all there is to it. And then once we get to a point, and so our folks at home understand when we do building airflow standards and we do a blower door test, that's going to give us a number. And that's what we base our corrections on. And so when we look at that number for infiltration, and that's air coming in, and what we want to do is an aggressive air loss reduction would be 30%. Mm-hmm. That's pretty aggressive.
Yeah.
And because the built space, not everything's accessible, and there's so many variables, man, we can get a 30% reduction. That goes a long, long way. And then maybe that's enough for our system to be able to handle that latent side. Right. But it's never a bad idea to do supplemental. And then
go ahead.
To get the other side of that, too little humidity, we have to add humidification.
Absolutely.
In the north, Michigan, Minnesota, New York, Ohio, a lot of those places, and they will add humidity.
Yeah.
And then they'll have a humidifier, dehumidifier, and then they have ventilation coming in.
Yeah. Mm-hmm.
Yeah.
Let's talk about the ventilation coming in. We got a little bit of time left, but I want to make sure to highlight your products and what you do, because you've invented probably the best inline filtration system, and you have a handle on fresh air makeup with positive pressure better than anybody that I've ever talked to. Okay. We talked to Nathan about this a little bit, but he got this from you.
Yeah, and just to clarify, if you will, I didn't invent it. Yeah, I like to always
reinvented the wheel.
I like to say, hey, I didn't invent the mousetrap.
Right.
I just built the best one.
Right.
And so you're referring to the Dust-Free 16. And so there's a V-Bank filtration is nothing new. Been around for a long, long time. And we actually have a competitor that has a product that's kind of like what we do. But when I went to Dust-Free and the engineers, and I had some pretty high standards. And what was cool, I worked 2 years with the engineers, and that was so much fun. And Devin is his name, and I said, look, here's our competitor. Here's what they're doing, and they're falling short. I said, we can do better.
Yeah.
And I said, here's what I want. I said, I need low static resistance, right? I need long filter life.
Yeah.
Right. I need I need to be user friendly. And so I need this to match up to most common furnace sizes. And then so what I did is I was able to bring the field into the lab.
Yeah, exactly.
And it was we came out with the DF16 ultra low static drop.
It's the best system I've ever seen.
98% filtration with 0.3 microns. We're just a step below a HEPA. And we're getting 3 years out of a filter change.
Yeah.
And so it's been amazing. It's on the market. You could buy it at truetechtools.com. There's a little plug. And it's fantastic. We're getting 3 years out of a filter.
Yeah.
In the right environment. And so that's just the quick version, but it's wonderful. It does everything we say it's going to do. Actually, our published performance data is conservative. I got guys putting them out in the field and coming back with better than published data.
Right.
And that was always our goal.
Yeah.
Yep. And so moving on, when we talk about ventilation, so why do we do ventilation? Well, it's good to have fresh air because air in the home. Well, I say fresh. Outside air, because air gets stagnant. Even if it's moving around, it's still the same air moving around.
Right.
And we cook and pets and have chemicals and cleaning and carpets and materials in our house. There's no place for them to go. They're just going to move around.
Right.
And so ventilation is used for dilution. You've heard the term dilution is the solution for the pollution.
Exactly.
Right. And that holds true for like TVOCs, carbon dioxide.
Everything.
And carbon dioxide is, in and of itself isn't that bad unless you're compromised, but we use it as a proxy to understand where our ventilation stands. And so there's some standards, different standards. I think ASHRAE is 1200 ppm. I like 600. It's where I try to achieve because there's other things that go on. Again, it's a proxy. And so if dilution by way of ventilation is what we're looking for to solve a problem, we also use ventilation for pressure differentials when we can. Right now, there's some things going on. The Santa Fe dehumidifying ventilator is fantastic. And there's others.
Yeah.
April Air's
got one, yeah.
So there's some others.
Yeah.
But that for the more humid climates, that's a game changer for us.
Absolutely.
But there's ERVs, HRVs, there's fresh air ducts. But in trying to solve a problem with ventilation by dilution and or just a healthier home for stagnant air, they only have a MERV 8 filter in them across the board.
Yeah.
And this is and that's a good filter. I think Santa Fe even has a MERV 13, and that's a great filter. And they keep the components clean. They don't fit in the housing all that well, and they don't do a whole lot of work on your PM 2.5.
No.
So as we're trying to solve a problem with ventilation, which we should, ASHRAE 62.2 is commonplace. We have an opportunity to load the house with PM 2.5 because our filtration just isn't there.
Right.
With TVOCs from outside sources, from agriculture, industrial, freeways, different things. And right now, ground source ozone is on the rise. And so...
Pun intended.
Unintended. And ozone happens naturally, but there's some things that we do as humans that are elevating those amounts as well. Once ozone gets into the house, and it's all bets are off because it reacts so radically with so many different things, even common products and everything. And so then we have a problem. Once you load a house, it is extremely hard to unload that house, especially if you're depending on ventilation to do it. So we in solving one problem, we have the potential to create a whole host of new problems. And so right now I am working on my next, and it's in the process now, and it's going up the flagpole. So I'm pretty confident we're going to see it through. But it is a complement to every ventilation strategy out there. I don't care whose sticker's on it.
Right.
And it will be 10 pounds of truly activated carbon.
Pelletized, right?
Pellet, not granule.
Correct.
It will be a HEPA filter, and it'll be a inline digital reverse incline fan to handle up to 1 inch of static resistance and do from 50 to 350 CFM.
That is awesome. And so you want to put a little bit of positive pressure
It has nothing to do with the pressures in the house.
It doesn't regulate any of that?
It's just to clean up that air coming in.
Just to clean it. Okay.
Yeah.
All right. Now, what do you think about adding that to a home? Can you combine that with that system?
Yes, we are designing it to be a complement to every ventilation strategy out there, no matter what manufacturer you are. And so it's an accessory. And and this is something that I did in my practice. I just built it out of components.
Right.
And this can be used as a standalone as well. It can be used to circulate air within a room through 10 pounds of carbon and a HEPA filter. And yeah.
That would be amazing. I can't wait for that to come out. So I better get a call.
You will.
I can't believe we're already out of time.
Yeah. We might have to do this again.
We're going to do this again. So I can't tell you how much I appreciate you and, again, your heart for people and the health of the home and just bringing your knowledge base and your experience and your wisdom to the indoor air quality industry. I think it's invaluable. So I'm telling all my friends about you, and as far as, you coming here to Nashville, it means a lot. So thank you for your time. And I'll tell you guys, there's no better guy to learn from here as it relates to the mechanical side, the indoor air quality side. His perspective, to me, I think is something that is missing in our industry. So the classes that you have, where can they find you as far as education?
So through Daikin and Manna Goodman, it would be on the HVAC Learning Campus. You would go on and request a training. I'm doing them privately now.
Yep.
And I can bring them to your location. I can bring them to your company. We can pull a group of people together and do them however you want to do that. I do have a lot of stuff online. If you Google John Ellis IAQ,
there you go. Yeah.
Got a lot of YouTube stuff out there and podcasts like this one. And And if you want to call me direct, here's where it gets crazy.
Okay.
505-652-8119. Call me. I get calls from all over the United States with people having problems. If you're on a job, whatever it takes. I'm in legacy mode. I'm passing the torch.
It's going to be like a bat signal.
I have never gotten a prank call.
Well, I so appreciate you being accessible to everybody. And thank you so much again for your time. Everybody, Yoda here in Nashville, thank you so much for watching.